Dear students, in this video we are going to see about the importance of turbulence, swirl, squish, tumble related to C.I.Engine. So it is essential to have well organized movement of air within the combustion chamber for speedy evaporation of fuel, to enhance air-fuel mixing, to increase combustion speed and to increase efficiency. Due to high velocities involved, the flow of air within the combustion chamber is turbulent. Due to the turbulence, the transfer rates like vaporization of fuel, heat transfer rates, mixing and combustion rates are greatly increased. The main aim of CI combustion chamber design is to ensure proper mixing of fuel with the air in a very short time. To achieve this well-organized movement of air is essential. The turbulence in the combustion ignition engines is quite systematic and built into the design. It would be desirable to understand various types of movements of the air within the combustion chamber. So turbulence is quite high during suction and recedes towards BDC. Again, during compression, the turbulence increases as swirl, squish and tumble. Okay, let us see what is swirl in the combustion chamber. The rotation motion of air within the cylinder is called swirl. So the swirl is achieved by a variety of methods like shaping the intake manifold, valve port and at times by suitably contouring the piston. Swirl enhances mixing and makes the flue air mixtures homogeneous. Swirl is the main mechanism to spread the flame within the combustion chamber. The swirl ratio used to indicate the extent of rotational motion within the combustion chamber if the ratio of average angular speed to the engine RPM. So there are different types of swirls. So first one is induction swirl. In the airflow is directed in a particular path while entering the cylinder. This method is generally employed for open combustion chamber. So second one is compression swirl. Here the swirl is produced during the compression stroke. Air is forced through a passage into a swirl chamber made separately during the compression stroke. The third one is combustion induced swirl. This swirl is produced by using phenomenon of a high initial pressure rise due to partial compression. Okay, next we will see about squish. What is squish? Radial inward movement of air while the piston reaches to the top dead center is called squish. It can be defined as radically inward flow of air towards the combustion recess by squeezing it out from between the piston and cylinder head during the end of the compression stroke. This movement of air is due to the fact that most of the modern chambers have clearance volume in the central portion only. While the piston moves to the top dead center, the air from the outer edges where there remains no space rushes towards the central portion, giving rise to the inwards radial motion. It is called a squish. Next we will see what is tumble. So this is the tumble. As the piston reaches close to the top dead center, the squish generates secondary motion about circumferential axis near the outer edges. So this motion is called tumble. So to achieve this, either the fuel is directed towards air or air is directed towards fuel. So basically there are three methods to create air movement or swirl during suction, compression or partial compression. So first one is open combustion chambers. So the combustion chamber in which swirl is produced during induction are called open combustion chamber or direct injection chamber. So next one is the turbulent combustion chambers. The combustion chamber in which compression stroke is used to produce a swirl are called turbulent or swirl combustion chambers. And the third one is pre-combustion chambers. So the combustion chambers in which partial combustion is used to create swirl or turbulence or air cell combustion chambers.